Apollo 11 was the name of a mission by which the first time humans landed on the moon.
Asteroids with D are larger rocks, and they are mostly in the asteroid belt between Mars and Jupiter. So the Sun, Mercury, Venus, Earth, Mars, and Jupiter, and then between there are lots of asteroids, larger rocks flying around in the asteroid belt. And they can bump together, and then they are creating smaller meteorites. So asteroid, the bigger one, and meteorite, the smaller one. And now if such an asteroid or meteorite, the smaller ones, asteroid big, meteorite smaller, happens to come into the atmosphere of Earth, they are called meteors, just because they are now in there. And when they are in the atmosphere of Earth, they are getting friction against the air. And that causes them to burn and burn away. Most of them if they're a bit smaller, and maybe leave a bit a tail behind, so some people call them also shooting stars. So meteors, shooting stars. And if such a meteor happens to hit the Earth and leaves a crater, it is a meteorite. A crater doesn't leave. There are also comets. Comets are not like asteroids out of rock, but comets are out of ice and dust. And they are traveling in big elliptical ellipses around the Sun. So asteroid, bigger one, mostly in the asteroid belt, then smaller one, meteorite. If they happen to come into the atmosphere of Earth, meteor or shooting star. If they hit the ground, meteorite. And that is according to Isabel Thomas, Out of This World, page 25. AU means astronomical unit. It is the distance from the Earth to the Sun, 150 million kilometers. Jupiter has 5, Saturn 9, and Uranus 19, and Neptune 30. And that is according to Cosmic Menagerie by Mark A. Garlick on the page 17. Ceres. Ceres is the first asteroid which was found. It was in 1801. And it is an asteroid which is in the asteroid belt between Mars and Jupiter. And there are around estimated 25 million asteroids, but Ceres is the biggest one with a diameter of 950 kilometers. There are only 3 other ones with a similar size. There are 4 in total over 500 kilometers in diameter. And 25 million, that is the number estimated for 100 meter asteroids. The number is 125,000.5% of the total number of the ones over 100 meter, which have more than 1 kilometer as a diameter. And that is according to Mark A. Garlick's Cosmic Menagerie book, page 21.
Twilight is the time in the morning and evening, from the begin of dawn, dusk, the sun being at 18 degrees below the horizon, and the sunrise, sunset, the sun being at 0 degrees below the horizon. Dawn is twilight called in the morning, dusk in the evening. In the morning, dawn happens from the sun being between 18 and 0 degrees below the horizon. At 18 degrees below the horizon, it is astronomical dusk. Astronomical twilight starts and lasts until 12 degrees below the horizon. At 12 degrees below the horizon, it is nautical dawn. Nautical twilight starts and lasts until 6 degrees below the horizon. At 6 degrees below the horizon, it is civil dawn. Civil twilight starts and lasts until 0 degrees below the horizon, then is sunrise. In the evening, dusk happens from the sun being between 0 and 18 degrees below the horizon. At 0 degrees below the horizon, it is sunset. Civil twilight starts and lasts until 6 degrees below the horizon. At 6 degrees below the horizon, it is civil dusk. Nautical twilight starts and lasts until 12 degrees below the horizon. At 12 degrees below the horizon, it is nautical dusk. Astronomical twilight starts and lasts until 18 degrees below the horizon. At 18 degrees below the horizon, it is astronomical dusk.
The 5 dwarf planets are Pluto, Eres, Ceres, Haumea, and Makemake. But it is suspected that trans-Neptunian, so further away from Neptune, there are around 100 more dwarf planets. That is according to Mark A. Garlick's Cosmic Menagerie book, page 22 and 23.
You want to stand up in the morning with your right foot. So in the morning you point with your right hand to the sun. The left side is east, so west where the sun is, and east, and you're looking to the north. In the evening it's the other way around. So you put your left hand the sun rising is east, you're facing north, it goes up, and down is south.
About 8 minutes and 20 seconds needs the light to travel from the sun to the Earth. It's not every day the same. Around the 3rd January, the Earth is closer to the sun and the light is around 2 seconds faster than on around the 4th July, when the light takes around 2 seconds longer. From neutron star to black hole. A neutron star is a massive star which had gone through a supernova explosion, followed by a gravitational collapse, by which the massive star was compressed and had reached high density. The high density causes the electrons and protons to combine to neutrons. After the massive star had had its gravitational collapse, which made it a neutron star, something referred to with neutron degeneracy pressure partially prevents the neutron star to collapse again. Additionally to the neutron degeneracy pressure, some other thing referred to with repulsive nuclear forces somehow supports the neutron star against collapsing. The so-termed Tolman-Oppenheimer-Volkow limit is 2.2 to 2.9 solar mass, and says that the neutron star with a mass of 2.2 to 2.9 times of the mass of a sun will collapse to a black hole. So the neutron degeneracy pressure and repulsive nuclear forces may prevent a neutron star with less than 2.2 to 2.9 solar mass from collapsing to a black hole, but if a neutron star has more than 2.2 to 2.9 times the mass of a sun, it will collapse and form a black hole. A massive star can have a supernova explosion followed by a gravitational collapse, compressing it to a neutron star. And if the mass of a neutron star is 2.2 to 2.9 the times the sun has of mass, neutron degeneracy pressure and repulsive nuclear forces are no longer sufficient to prevent the neutron star from collapsing. And the neutron star collapses and forms a black hole.
IC1101. IC1101 is the name of the largest so far found galaxy. And it is 50 times larger than the Milky Way. The Milky Way is the galaxy in which the solar system of the Earth is. And already in the Milky Way, the light needs 100,000 years to travel from one side to the other one, and that IC1101 is 50 times larger. The Milky Way has already 100 billion stars, and that IC1101 has 100 trillion stars. That is according to Isabel Thomas out of his World Book, page 30.
Info snippets to astrophysical jets. Astrophysical jets are an astronomical phenomenon. Astrophysical jets exist by so-called supermassive black holes. Astrophysical jets can occur besides of by supermassive black holes by quasars, radio galaxies, or within galaxy clusters. By astrophysical jets, something is emitted. Ionized matter is emitted through astrophysical jets. Supermassive black holes, quasars, radio galaxies, or within galaxy clusters, ionized matter can be emitted through astrophysical jets. If the emitted ionized matter is so fast emitted by the astrophysical jets that the speed of the emitted ionized matter is close to the speed of light, the astrophysical jets are called relativistic jets. There are some ideas how astrophysical jets happen. One try to explain astrophysical jets is that inside of the black hole magnetic fields are tangled. The idea is that they are tangled in a way that if ionized matter is emitted through them, the ionized matter comes not irregular at different sides out of the magnetic field, but only through a narrow beam. By this explanation try, the magnetic fields would be tangled along the diameter of the black hole, and the ionized matter would come out through astrophysical jets at both ends of the diameter of the black hole. Info snippets to electromagnetic fields are: an electromagnetic field is a physical field. An electromagnetic field varies in space and time. An electromagnetic field represents the electric and magnetic influences. Electric and magnetic influences can be generated and can act upon something. By electric charges, electric and magnetic influences can be generated, and on electric charges, electric and magnetic fields can act upon. The electromagnetic field can be regarded as a combination of an electric field and a magnetic field. A disturbance in the electric field can create a disturbance in the magnetic field. If the electric field disturbs the magnetic field disturbs the electric field back. This back and forth of affecting of electric field disturbing the magnetic field and the magnetic field disturbing the electric field back leads to an oscillation. The oscillation from one affecting the other and the other affecting the other back propagates through space. This oscillation, which propagates through space, is called electromagnetic wave. Short info snippets to kinetic energy are that it is a form of energy, that an object can be in motion, that the form of energy an object has due to its motion is kinetic energy, and that a non-rotating object can have a mass m, and that a non-rotating object can travel with the speed v, and that the kinetic energy of a non-rotating object with a mass m and the travel speed v is 1/2 mv superscript 2. Info snippets to muons are that muons are elementary particles, that muons are similar to electrons, that muons have the same electric charge as electrons. Muons and electrons have the same electric charge of -1 e, but muons have a much greater mass than electrons. Subatomic particles exist. Subatomic particle can be unstable. The muon is an unstable subatomic particle. Unstable subatomic particles have a mean lifetime. The mean lifetime of a subatomic particle muon is 2.2 microseconds. The mean lifetime of a subatomic particle muon is with 2.2 microseconds much longer than by other subatomic particles. The mean lifetime of a subatomic particle muon is with 2.2 microseconds much longer than by other subatomic particles. The decay is slow compared to other subatomic particles. The types weak interaction and strong interaction exist. The decay of a subatomic particle muon is slow because the decay is only mediated by the type weak interaction. When a muon decays, it results in a decay product. The mass of a muon and the mass of its decay product is different. The difference of the mass of a muon and the decay product of a muon is small. Kinetic degrees of freedom do exist. The kinetic degrees of freedom can be more or less. Because the difference of the mass of the muon and its decay product is small, there are only few kinetic degrees of freedom. And because there are only few kinetic degrees of freedom, the decay is slow. A muon is an elementary particle, and the decay product of a muon are multiple particles. The decay product of the muon are at least 3 particles. These minimum existing 3 particles of a decay product of a particle muon must include 1 electron and 2 types of neutrinos. The electron out of the at least 3 particles of a decay product of muon has the same charge as the muon. The particle muon has an antiparticle anti-muon. Muons have a charge of -1 e, the anti-muon of +1 e. The anti-muon has a different charge than the muon, but the same mass. Muons and electrons can accelerate and decelerate. In an electromagnetic field, muons and electrons can accelerate. Braking radiation exists. When muons and electrons are accelerated in a magnetic field, the breaking radiation happens. Muons have a greater mass than electrons, and because muons have a greater mass than electrons, they accelerate slower than electrons. And when the acceleration is slower, the breaking radiation is lower. When muons or electrons are accelerated in an electromagnetic field, the more massy muon accelerates slower and less breaking radiation happens. When breaking radiation happens, this leads to energy loss. Muons and electrons can penetrate into matter. Muons and electrons need energy to penetrate into matter. The electron accelerates fast, so that much breaking radiation happens. Because the electron loses much energy through the breaking radiation, it cannot penetrate any more that deep into matter. The muon has a great mass and accelerates slowly in the electromagnetic field and emits only little breaking radiation. And because it is that the slow acceleration of a muon creates only little breaking radiation, the muon does not lose so much energy. Muons have a greater mass than electrons. When muons and electrons accelerate in an electromagnetic field, breaking radiation is emitted. Because of a greater mass of electrons, accelerating electrons emit more breaking radiation than muons, who because of their small mass accelerate slower and emit less breaking radiation. And because electrons are losing more energy through the greater breaking radiation than the muons have more energy left to penetrate deeper into matter. So-called secondary muons created by cosmic rays can penetrate through the atmosphere and travel even into deep mines. Info snippets to neutrino detectors are that a neutrino detector is an apparatus, that neutrinos exist, and that a neutrino detector is an apparatus designed to study neutrinos. That neutrinos interact only weakly with other particles, and therefore that the neutrino detector must be very large. Background radiation and cosmic rays also exist, and to isolate the neutrino apparatus from the background radiation and cosmic rays, these neutrino apparatus are often built underground. Super Kamiokande is the name of an observatory trying to detect neutrinos. In Super Kamiokande, there is a large volume of water. The large volume of water in Super Kamiokande is surrounded by phototubes. The so-called Cherenkov radiation can be emitted. An incoming neutrino can create an electron or muon. The so-called Cherenkov radiation is emitted when an incoming neutrino creates an electron or muon. In Super Kamiokande, the Cherenkov radiation is emitted when an incoming neutrino creates an electron or muon in the large volume of water. The phototubes surrounding the large volume of water in Super Kamiokande are waiting and watching for the emitted Cherenkov radiation when an incoming neutrino creates an electron or muon in the large volume of water. Info snippets to neutron stars. So-called massive stars exist. A massive star can explode. The explosion of a massive star can be a supernova explosion. After the massive star had a supernova explosion, a so-called gravitational collapse can happen. During a gravitational collapse, the star is compressed. When a massive star has after a supernova explosion a gravitational collapse, the star is compressed. Because the star is compressed after the gravitational collapse following the supernova explosion, it reaches a high density. A neutron star is a massive star which had a supernova explosion, followed by a gravitational collapse which compressed the massive star. Neutron stars don't generate heat anymore and they cool down. It is assumed that neutron stars are mostly composed of neutron, because the extreme density through the gravitational collapse after the supernova explosion had caused the electrons and protons to combine to additional neutrons. A neutron star can collapse further into a black hole. New neutron stars are very hot. The cooling down process takes many million years. Neutron stars can rotate several hundred times per minute. Info snippets to photosynthetically active radiation. Solar radiation exists. Not all solar radiation is the same. Something of light can be measured in nanometers. 1 meter are 1 billion nanometer. 1 billion nanometer are 1 meter. Something of light can have a length. If this length is somewhere between 400 and 700 nanometers, that is then photosynthetically active radiation. If this one particular thing of light has a length between 400 and 700 nanometer, and is because of that photosynthetically active radiation, it is the light that organisms which are doing photosynthesis can use to do this just mentioned photosynthesis. Photons, which have something to do with light, are dangerous to cells and tissue if their wavelength is shorter than 400 to 700 nanometers. These photons, which are dangerous when their wavelength is shorter than the photosynthetically active radiation length of 400 to 700 nanometers, are mostly filtered by something called ozone layer, which is somewhere in something called stratosphere. These shorter photons are more energetic, therefore dangerous. If they are longer than the spectral range of 400 to 700 nanometers of the photosynthetically active radiation range, then they are not energetic enough to allow photosynthesis. Shorter than 400 nanometers, dangerous. 400 to 700 nanometers, fit for photosynthesis. That is the photosynthetically active range. Longer than 700 nanometers, not energetic enough to be fit for photosynthesis. Whatever it is, cyanobacteria, purple bacteria, and heliobacteria exists, and they can use light outside of these 400 to 700 nanometers range of the photosynthetically active radiation spectrum, and so it happens that they can live in stagnant pools, sediments, and down in the depths of the unfathomable oceans. Photosynthetically active radiation measure is important in agriculture, to know if onto that field by these many clouds, their height on that mountain and the shadow of that mountain so close to the equator during that season, so and so much photosynthetically active radiation comes, which the plants can use to grow, because its wavelength is between 400 and 700 nanometers, which is between the 15 and 25,000th of centimeters length. Info snippets to pulsars. Neutron stars exist. A neutron star can rotate. A rotating neutron star can be magnetized. A magnetized rotating neutron star can have magnetic poles. Out of magnetic poles, electromagnetic radiation can come. A magnetized rotating neutron star can emit electromagnetic radiation out of its magnetic poles. When a magnetized rotating neutron star emits electromagnetic radiation out of its magnetic poles, it is called pulsar. A pulsar is a magnetized rotating neutron star which emits electromagnetic radiation out of its magnetic poles. The electromagnetic radiation can be on Earth observed if the electromagnetic beam exiting the magnetic pole of a magnetized rotating neutron star shoots into the direction of the Earth. Because the electromagnetic beam exiting a magnetic pole of a magnetized rotating neutron star can only be observed in pulses whenever the beam points to the Earth, it is called pulsar. Pulsars are very dense and are having a short and regular rotational period. Because the rotation of pulsars are so regular, the pulses of electromagnetic radiation are also regular. The pulses of the electromagnetic radiations can have intervals of milliseconds to seconds. Because the pulses of electromagnetic radiation are so regular, they can be of use for astronomers. Pulsars are a source of so-called ultra-high energy cosmic rays. Observing of a pulsar in something referred to as binary neutron star system was used to indirectly confirm gravitational radiation. Some basic introduction snippets to quantum electrodynamics are: quantum electrodynamics is part of particle physics. Electrodynamics exist. The quantum field theory exists. And the theory of relativity exists. And quantum electrodynamics is now the relativistic quantum field theory of electrodynamics. Light and matter exist. Quantum electrodynamics describes how light and matter interact. Electrically charged particles can interact by exchange of photons. Quantum electrodynamics describes mathematically how electrically charged particles interact by exchange of protons. Quantum electrodynamics is a very accurate way to calculate the position, movements, and quantity of particles. Info snippets to superluminal motion. Superluminal motion is part of astronomy. Energy exists. Bursts of energy can be emitted. Bursts of energy can be emitted in so-called radio galaxies. Bursts of energy emitted by radio galaxies have a speed. Light itself has a speed. The speed of the bursts of energy, which are emitted by radio galaxies, can appear to be faster than the speed of light. It appears that the burst of energy coming out of a radio galaxy is faster than light. It is motion which appears to be superluminal. Superluminal motion is the motion of energy bursts coming from radio galaxies which appears to be faster than light. Beside of radio galaxies also, BL-like objects, quasars and blazars can emit bursts of energy with superluminal motion. It is thought that radio galaxies, BL-like objects, quasars and blazars contain a black hole, which is responsible to emit energy bursts which appear to be faster than light. Info snippets to the matter wave from quantum mechanics. The theory of quantum mechanics exists. Matter waves are a central part of a quantum mechanics theory. Matter wave means that matter exhibits wave-like behavior. A light beam can be diffracted from its original path. A beam of electrons can be also diffracted from its original path. The concept that matter behaves wave-like was proposed by Louis de Broglie in 1924. Wave-like behavior was first at electrons demonstrated, that was in 1927. Besides of electrons, wave-like behavior was also demonstrated for elementary particles, neutral atoms and molecules. The matter wave has a wavelength, named lambda. The particle doing the matter wave has a momentum, named p. The Planck constant exists and is named h. Electrons, neutrons and atoms have different wavelengths. The matter wave's wavelength can be calculated. The matter wave's wavelength can be calculated by dividing the Planck constant through the momentum of a particle which is doing the matter wave. The wavelength lambda is the Planck constant h divided by the momentum p of a particle which is doing the matter wave. Lambda equals h divided by p. The concept of matter waves is used in the study of materia. Info snippets to the Planck relation. The Planck relation is a part of quantum mechanics. The Planck relation is an equation in quantum mechanics. Photons exist. Photons have energy called E. The energy of a photon has frequency. The energy of a photon is in proportion to the frequency of the energy. The Planck relation states that the energy of a photon is in proportion to the frequency of the energy. The Planck constant exists. The Planck constant is called h. E is the energy of a photon. H is the Planck constant. And V is the frequency of the energy. The energy of a photon is the Planck constant multiplied with the frequency of the energy. E equals hv. The Planck relation is important by the photoelectric effect and the blackbody radiation. Info snippets to virtual photons. Virtual photons are a concept in particle physics. Virtual photons are a concept in particle physics and in the quantum field theory. Electrically charged particles exist. Virtual photons are a concept describing the interactions of electrically charged particles. So-called free particles exist. Virtual photons do not exist in the same sense as free particles. Virtual particles serve as intermediate particles. Between particles, force can be exchanged. Virtual particles serve as intermediate particles by the force exchange of other particles. Between two particles can be an electromagnetic force. Virtual photons are exchanging between two particles. The exchange of virtual photons between two particles creates the electromagnetic force between the two charged particles. There are positive virtual photons and negative virtual photons. Whether they are positive virtual photons or negative virtual photons depends on the energy, momentum, and their contribution to the electromagnetic force. Info snippets to wave-particle duality. Quantum mechanics exist. Wave-particle duality is a concept in quantum mechanics. Photons and electrons exist. Photons and electrons and other fundamental entities exist. Photons and electrons or others can exhibit particle or wave properties. Wave-particle duality is the concept that photons or electrons or others exhibit particle or wave properties. In the 19th century, it was thought that light behaves like a wave, but it's actually more particle-like. In the 19th century, it was thought that electrons behave like particles, but it's actually more wave-like. The introduction to the German language Wikipedia article to wave-particle duality, and it's translated with Google Translate from German to English. Wave-particle duality is a quantum physics insight according to which quantum objects must be attributed the properties of both classical waves and classical particles. Classical waves propagate through space. They weaken or strengthen each other through superposition and can be present in different places simultaneously, exerting different effects. A classical particle can only be present in one specific location at a time. These two properties appear to be
mutually exclusive. Nevertheless, several key experiments have demonstrated that both properties exist for various quantum objects, so that every body is attributed a matter wave. The question of whether electrons or light quanta are particles or waves cannot be answered. Rather, they are quantum objects that exhibit different properties depending on the type of measurement performed on them. This problem was initially solved in quantum mechanics in the Copenhagener interpretation 1927 with a complementary principle formulated therein. It stated that the determination of the observed property cannot be attributed solely to the quantum object, but represents a phenomenon of the entire arrangement of quantum object and measuring apparatus. Later, a number of other interpretations of quantum mechanics emerged with alternative explanatory approaches. Wave-particle duality does not occur in everyday life because the wavelength of the matter wave in macroscopic bodies is far too small to cause phenomena that can be clearly explained only by wave-like behavior. At very small wavelengths, the wave and particle models agree in their observable consequences, despite the different approaches, as was already known from the relationship between ray objects and wave objects. On the other hand, wave-particle duality is by no means limited to the smallest quantum objects. It has also been demonstrated experimentally for the large molecules consisting of over 800 atoms. Quantum field theory understands both particles and interactions as discrete excitations of fields. Thus, there is no formal distinction between these two categories. For visualization, however, the problem remains that both of these opposing views apply here. The original German. Der Welle-Teilchen-Dualismus ist eine Erkenntnis der Quantenphysik, wonach den Objekten der Quantenphysik gleichermaßen die Eigenschaften von klassischen Wellen wie die von klassischen Teilchen zugeschrieben werden müssen. Klassische Wellen breiten sich im Raum aus. Sie schwächen oder verstärken sich durch Überlagerung und können gleichzeitig an verschiedenen Stellen präsent sein und dabei auch verschieden stark einwirken. Ein klassisches Teilchen kann zu einem Zeitpunkt nur an einem bestimmten Ort anwesend sein. Beide Eigenschaften scheinen sich gegenseitig auszuschließen. Trotzdem wurde in mehreren Schlüsselexperimenten für verschiedene Quantenobjekte belegt, dass beide Eigenschaften vorliegen, so dass man jedem Körper eine Materiewelle zuschreibt. Die Frage, ob Elektronen oder Lichtquantenteilchen oder Wellen seien, lässt sich nicht beantworten. Sie sind vielmehr Quantenobjekte, die je nach der Art der Messung, die man an ihnen durchführt, unterschiedliche Eigenschaften in Erscheinung treten lassen. Dieses Problem wurde in der Quantenmechanik in der Kopenhagener Deutung 1927 mit dem dort formulierten Komplementaritätsprinzip zunächst dahingehend gelöst, dass die Festlegung der jeweils beobachteten Eigenschaft nicht allein dem Quantenobjekt zuordnen sei, sondern ein Phänomen der gesamten Anordnung aus Quantenobjekt und Messapparatur darstelle. Später entstanden eine Reihe weiterer Interpretationen der Quantenmechanik mit alternativen Erklärungsansätzen. In der Alltagswelt taucht der Welle-Teilchen-Dualismus nicht auf, weil die Wellenlänge der Materiewelle bei makroskopischen Körpern um vieles zu klein ist, um Phänomene hervorzurufen, die eindeutig nur mit wellenartigem Verhalten zu erklären sind. Bei sehr kleinen Wellenlängen stimmen Wellenbild und Teilchenbild nämlich trotz der verschiedenen Ansätze in ihren beobachtbaren Konsequenzen überein, wie aus dem Verhältnis von Strahlenobjekt und Wellenobjekt schon früher bekannt war. Andererseits ist der Welle-Teilchen-Dualismus keineswegs auf die kleinsten Quantenobjekte beschränkt. Er wurde im Experiment auch schon für große Moleküle aus über 800 Atomen nachgewiesen. Die Quantenfeldtheorie versteht sowohl Teilchen als auch Wechselwirkungen als diskrete Anregungen von Feldern. Damit gibt es auf der formalen Ebene keinen Unterschied zwischen diesen beiden Kategorien. Für die Anschauung allerdings bleibt das Problem, dass die zwei gegensätzlichen Bilder hier beide gelten. Court of Justice of the European Union judgment from the 16th July 2009, paragraph 35. Similar, under Articles 1.3 of Directive 91-250, 3.1 of Directive 96.9 and 6 of Directive 2006-116, works such as computer programs, databases or photographs are protected by copyright only if they are original in the sense that they are their author's own intellectual creation.
Corpus omne perseverans status suo quiscendi, quel movimento uniformata in directum nisi quatenus ervibus impressis cogitus datum illum mutar. Newton's third law of motion, if two bodies exert forces on each other, these forces have the same magnitude but opposite directions, is in original Latin. Actioni contrariam semper et equalum esse reactionem, sivi corporum duorum actionis in se mutuus semper esse equales et in partes contrarias dirigit.
What is metallicity? Metallicity is something in astronomy. The two elements hydrogen and helium exist. There are elements which are heavier than hydrogen or helium. And the metallicity says how many elements there are which are heavier than hydrogen or helium. Metallicity says how many elements an object has which are heavier than hydrogen or helium.
Moons in the solar system. So there's the Sun, and Mercury and Venus have no moons. And Earth has one moon, and then Jupiter and Saturn, the two gas giants, they have both over 60. Each of them has over 60 moons. And Uranus and Neptune have also moons. And now, Jupiter has a moon called Europa, and that Europa moon has twice as much water as Earth has. And Saturn has a moon called Titan, and the Titan has a thick atmosphere and is bigger than the whole planet Mercury. And that is according to Isabel Thomas out of the Space Book, page 22 and 23. A neutron weighs 939.6 mega-electrovolts and a proton 939.3 mega-electrovolts. That is a difference of 0.14% is the proton lighter than the neutron. But they're both still more than 1,800 times heavier than an electron. That is according to Richard Webb's Particle Physics, Understanding Reality's Building Blocks book, page 38.
If you are a moving force and you step down, your leg stands on the ground, but you keep moving forward the upper part of the body, and you fall down. If you come and suddenly jump, you will be there. The thing you have stand on moves on, but you stand there. So if you step and keep standing, one part of your body keeps going and you fall down. So you jump. This jump bears, of course, risk of injury for feet, ankles and legs. But more importantly, your moving force forward can be dangerous, even lethal. Planet. The left hand a fist and the right hand the letter P. The third and the second finger are extended and the thumb in the middle, and then around like the orbit of a planet. Planet.
Proxima Centauri. Proxima Centauri is a part of the Sun, the closest star to the Earth. It is 40 trillion kilometers away from the Earth. The Sun is 150 million kilometers away. With a spacecraft, it would take thousands of years to get there. It is a fairly small and dim star, so that it can't be seen with the naked eye on the sky. A telescope has to be used. That is according to Isabel Thomas out of this world on the page 31.
Sir Isaac Newton, he studied at Cambridge, and his most famous work is Philosophia Naturalis Principia Mathematica, mathematical principles of natural philosophy, and that was about gravity and how it applies to the whole universe. He also discovered that light has not just the color of light, but that it is composed out of multiple different colors. And his ideas are still important for the world today. And he was a member of the Royal Society, which was formed by Charles II. Sir Isaac Newton, born in Lincolnshire in England, 1643-1727. And that is according to the Life in UK Test Handbook, page 30 and 31.
The four classic states of matter are solid, liquid, gas and plasma. Solid, liquid, gas and plasma.
Space begins 100 kilometers above the surface of the Earth at the Karaman Line. It can't be really said where space begins and the Earth's atmosphere ends because the air just gets thinner and thinner, but most scientists have agreed on the made-up invented Karaman Line 100 kilometers above the surface of the Earth. And an astronaut who had went with a spaceship above that line can say that that person has went to space. And that is according to the Out of This World book by Isabel Thomas on the page 6. Spiral, lenticular, elliptical, and irregular shaped galaxies. They are the spiral galaxies. They basically look like a star which is turned and the arms are hanging behind. And when there are the lenticular galaxies, they are looking a bit like the lens out of a magnifying glass. And then there are the elliptical galaxies. They are oval, almost like an egg. And then there are the irregular shaped galaxies. They are irregular shaped. 2/3 are the spiral-shaped ones, the turning ones with these arms out, and the Milky Way is one of these spiral-shaped galaxies. That is according to Out of This World by Isabel Thomas, page 33. The temperatures of the Sun. In the core, it are 15 million degrees Celsius. At the surface, it are 5,500 degrees Celsius. And at the outer layer of the atmosphere, the outer layer is called corona of the Sun, where it are 1.7 million degrees Celsius. So the core, 15 million, and the surface, 5,500. But this atmosphere up to the outer layer called corona of the Sun, 1.7 million degrees Celsius. That is according to Isabel Thomas, Out of This World book, page 14. Terrestrial planets are planets with a rocky or solid surface. The Earth is a terrestrial planet. They are also called telluric planets. It comes from the Latin words for Earth, terra, terrestris, or tellus. And now telluric or terrestrial planets are planets with a rocky or solid surface. In the solar system, these are a part of the Earth, also Mercury, Mars, and Venus. That is according to Mark A. Garlick's Cosmic Managerie book, page 18.
The 17 elementary particles of a standard model of particle physics are of the quarks and antiquarks, up, down, charm, strange, top, bottom, of leptons and antileptons, electron, neutrino, muon, neutrino, tau, neutrino, of the Gauge bosons, gluon, photon, W boson, Z boson, and of the scalar bosons, the Higgs boson. The three laws of motion by Isaac Newton are: 1. A body remains at rest or in motion at a constant speed in a straight line unless it is acted upon by force. 2. At any instant of time, the net force on a body is equal to the body's acceleration multiplied by its mass, or equivalent, the rate at which the body's momentum is changing with time. 3. If two bodies exert forces on each other, these forces have the same magnitude, but opposite directions. The four fundamental types of interactions are weak interaction, strong interaction, gravitational interaction, and electromagnetic interaction. The 5 museums of the Science Museum Group are the Science Museum in London, the National Railway Museum in York, the Science and Industry Museum in Manchester, the Science and Media Museum in Bradford, and the Locomotion Museum in Durham. SI is the System International de Units, International System of Units, and the 7 base units of it are S, second, the time needed to say Mississippi, M, meter, step-wide distance, kg, kilogram, the combined weight of both hands, big A, ampere. 1 ampere are 6,241,509,074 times 10 raised minus 19 elementary charges moving in 1 second. An elementary charge is the electric charge carried by one proton. Protons are inside of atoms. Depending on how much protons are inside the atom, it is defined what element it is. When the atom has 79 protons, the stuff is called gold. If it are 26, iron, and when 8, it's oxygen. Uppercase K, Kelvin, to measure thermodynamic temperatures. Water freezes to ice at 273.15 Kelvin. At 373.15, it boils. Kelvin is shifted from Celsius by 273.15 degrees. A warm summer day with 20 degrees Celsius has 293.15 Kelvin. Mole, it is how much mass 1 mole of a substance has. 1 mole are 6,022,140,076 times 10 raised 23, 602 billions times a trillion. This number is called the Avogadro number and has the sign N, and direct next to it but lower is 0. CD, candela, how much light comes from a lamp into a specific direction. One candle has around 1 candela. Lumina, the total amount of light from the lamp. A torch can have in total not so much lumen, but because the light is focused in one direction, it can there be still bright enough.
The 8 planets from the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The Asteroid Belt. The Asteroid Belt is between Mars and Jupiter. So with the Sun, then it's Mercury, Venus, Earth, and then Mars and Jupiter, they're between, and then there come also Saturn, Uranus, and Neptune. So between Mars and Jupiter, there's the Asteroid Belt. And these are a bunch of asteroids just around the Sun, or they go there. They are just there. And now there are 25 million which are bigger than 100 meter, and 125,000 which are larger than 1 kilometer, and 4 of them are larger than 500 kilometers. And the biggest one of them, discovered in 1801, first asteroid discovered, is Ceres. That one is 950 kilometers in its diameter. And that is, and they are mostly out of carbon stuff or metallic or stone material. They are basically leftover chunk from when the solar system was forming, which has not formed into planets as the other parts. And that is according to Mark A. Garlick's Cosmic Planetary book, page 21. The colliding of the Milky Way with other galaxies. The Milky Way is currently colliding with another galaxy, a smaller one, and the smaller one is getting torn apart and drawn towards the center of the Milky Way. And there's another galaxy falling towards the Milky Way that will take billions of years until it hits, and also the collision with the other one takes hundreds of millions of years. Just in the universe visible from Earth, there are 2 trillion galaxies, and they are constantly moving around and pulling at each other and colliding into each other. And scientists believe that the colliding of the Milky Way with this other galaxy has caused the Milky Way to be a spiral galaxy with all these arms. That is according to Isabel Thomas out of this world book, page 35. The Sun has a diameter of 1.4 million kilometers. So once across from the Sun are 1.4 million kilometers. And that is 109 times the width of the Earth. And that is according to Out of This World by Isabel Thomas on the page 30.
The equation for the universal gravitation is F equals G times m1 times m2 divided by r raised to, or G times the product of m1 and m2 divided by r squared. Or the gravitational force F between 2 objects is the mass of object 1, m1, and the mass of object 2, m2 multiplied. This result then divided by the squared distance of the centers of the 2 objects. R is the distance, r raised to is the distance squared. The outcome of this is then multiplied by the gravitational constant g. Or, differently expressed, the gravitational force between 2 objects is the mass of the first object multiplied by the mass of a second object divided by the squared distance of these objects multiplied with g. Every object has a gravity and pulls things towards it. The strength of this pulling gets bigger when the object has more mass, and smaller if the object has less mass. But everything and everywhere, as long as it has the same mass, pulls with the same strength. And there was just a name needed for this pulling of every object, which is everywhere the same as long as the objects have the same mass. It ended up being gravitational constant, and goes by g. And g is 6.6743 times 10 raised minus 11 times m raised 3 times kilogram raised minus 1 times s raised minus 2.
The far side of the Moon. On the far side of the Moon is basically the same as on the side pointing to the Earth. But there are fewer plains and the mountain ranges are up to 5 kilometers higher. And there are also more craters because that is the place where all the asteroids can come in. Where the Earth is where cannot come in the asteroids. So on that side, on the far side of the Moon, are more craters. And people wanted to know what is there. So in 1959, the Soviet Union sent out a space probe to take pictures. And that's the reason why many places they are called after Soviet people and Soviet places. How the Moon stands always like that in one direction because it's just locked. It goes in 1 month around the Earth, but it turns around its own axis once a month. So its face is always with the same side towards the Earth. And that is because that side is heavier of the Moon than the other one. So it stays always like that. and most of it is according to Out of This World by Isabel Thomas. The formation of Jupiter. When the solar system was quite new, there it was hot by the sun and further out colder. Close by the sun, iron rocks could get firm, but icy substances not. At 800 million kilometers away from the sun at the snow line, which is 5 times far away from the sun as Earth is, there it was cold enough and icy substances could cool down. And now all these icy substances stick together and one big snowball created, and this one big snowball was the beginning of Jupiter. And it had 15 times the mass of the Earth, this snowball. And now because it had 15 times the mass of the Earth, it had a lot of gravitation and was able to pull in the hydrogen and the oxygen in its orbit. And over some 100,000 years, it pulled all the hydrogen and helium towards it. And when Jupiter happened to be. And Jupiter is now there, and it has the kernel, has the size of the Earth, and had then already 15 times the mass of the Earth. And now the whole Jupiter is 11 times as large as the Earth. It is in the inside, an icy kernel, also some rocks are there, but it's an icy kernel, 15 times the mass of the Earth, with a lot of gravitation, and pulling all the helium and hydrogen towards it, so that the thing is a big ball in the middle, a big gravitational point with the icy substances, and surrounded all the gases, all the helium and the hydrogen. And that is according to Mark Garlick's Cosmic Menagerie, page 40. The Karaman Line is 100 kilometers above Earth's surface, and above it is space. People were thinking where the space begins. The air just gets thinner and thinner. And so they came together and then decided we're going to do the Karaman Line, and that is 100 kilometers above the Earth, and everything above it is space. And people who have flown with a spaceship above that line, so more than 100 kilometers above the Earth's surface, are considered astronauts. The Karaman Line is an invented, made-up line 100 kilometers above the Earth's surface, and from that point onwards, space begins. And that is according to Isabel Thomas' Out of This World book, page 6.
The masses of the other planets relatively to Earth are, for Mercury, 0.05, Venus 0.8, Mars 0.1, Jupiter 318, Saturn 95, Uranus 15, and Neptune 17.
100 billion. The Milky Way has 100 billion stars in it. That is according to Isabel Thomas' Out of This World book, page 30.
The moon Europe was discovered by Galileo Galilei on the 8th of January 1610. The most abundant elements in the Earth's crust are oxygen 46%, silicon 28%, aluminium 8%, iron 6%, calcium 4%, sodium 2.3%, magnesium 2.3%, potassium 2.1%, titanium 0.5%, hydrogen 0.1%. Most common elements in the Milky Way galaxy are hydrogen, helium, oxygen, carbon, neon, iron, nitrogen, silicon, magnesium, and sulfur. The northern solstice is June 20, 21-22, when in the northern half of the Earth, the daylight is the longest. Accordingly, in the southern half, it is the shortest.
The patchy, shadowy spots, darker spots on the moon, they are places where billions of years ago was lava, but that lava had cooled down. And now these places are darker, they are reflecting less sunlight than the mountains around them. The ancient Greeks thought these were lakes, oceans, seas, and when maps were created, then they had given these darker spots lake and ocean names like Marsh of Decay. But through telescopes, probes, and exploring, we know that on the moon there is no water at all. And these places, these darker shadowy spots on the moon, are places where lava had flown probably some billion years ago. And that is according to Out of This World by Isabel Thomas on the page 9.
Solid, liquid, gas, plasma. Solid does melting. Liquid can freezing or vaporization. Gas can condensation or ionization. Plasma recombination. Solid can also sublimation and gas deposition. Melting, vaporization, ionization, recombination, condensation, freezing. Melting becomes liquid, vaporization gas, ionization plasma, recombination gas, condensation liquid, freezing solid. Solid melting liquid, liquid vaporization gas, gas ionization plasma, plasma recombination gas, gas condensation liquid, liquid freezing solid. As a bonus, solid can directly become gas and backwards gas can become solid. Solid to gas sublimation and gas to solid deposition. Solid sublimation gas, gas deposition solid.
The Sun is 150 million kilometers afar from the Earth. The light needs 8 minutes to travel from the Sun to the Earth, and the humans have built a satellite called the Solar Probe Plus, and that thing can travel with 720,000 kilometers per hour. With that thing, it would take 30 seconds from London to New York, and that satellite will need 6 years to travel from the Earth, the 150 million kilometers to the Sun. And that is according to Out of This World by Isabel Thomas, page 15. There are 8 planets in the solar system, and the 4 terrestrial ones are the first 4. There is Mercury, Venus, Earth, and Mars. They are terrestrial. And then there are the 2 gas giants, Jupiter and Saturn, and the 2 ice giants, Uranus and Neptune. And that is according to several pages of Mark A. Garlick's Cosmic Meteorology book, for example, page 18.
Mainland Portugal has the same time as the United Kingdom. Central Europe is an hour forward to them. Tornadoes turn in the north half, this part, of the Earth counterclockwise when viewed from both. In the southern half of the Earth clockwise when viewed from above. This rotation pattern is called cyclonically, caused through the Coriolis effect. The tornado turns in the same direction as the planet. The Earth viewed from the north turns counterclockwise. So if you look from here, this turns counterclockwise. The Earth viewed from the south turns clockwise. If you look from here, this turns clockwise. The tornado turns clockwise. 1% of tornadoes turn the other way around. They are called anticyclonic tornado.
In 1983, the W and Z boson was confirmed at the CERN in Switzerland, and in 2012, the Higgs boson at the same institution in Switzerland. And that is according to particle physics on the page 40. The reason why the Moon appears to have the same size as the Sun from Earth was seen is because the Sun is 400 times further away than the Moon. And now because the Sun is 400 times further away, even though it is around 400 times bigger than the Moon, it appears to have the same size seen from the Earth. Now, and I'm going to show it in a moment here. There's this football, which is around 5 times as big as a tennis ball. And now this football is around 5 meters far from the camera. If we go now closer, and this tennis ball is now 1 meter away from the camera to the football, then they appear to have the same size. And now also, like a solar eclipse, the Moon can come before the football and block it. So that's all. And that was according to Out of This World by Isabel Thomas, page 13.